Hi students, we're going to discuss about decoder. What is a decoder? What are the applications of decoder? How we can realize the Boolean equation by using decoder? And then we're going to discuss about encoder. What are the problem is encountered in encoder? And then how to overcome of the encoder? Then some of the application in encoder with some of the examples. So these are the things we're going to discussing in this module. Let me see that the definition of a decoder. Digital information represented in some binary form must be converted into some alternate binary form. That means that it converts one form of coded input into another form of coded output. So what is a combination of a decoder? So there is an n input, so we should have a 2 power n outputs, so that is the line decoder. So here only one of 2 power n output lines responds with the logic 1 to a given input combination of values on its n input line. So that means that we have an n input combinations with n input combinations. So in that we have the 2 power n outputs lines, that will be only one line will be responded as a logic 1 when your outputs of a decoder is active high. Remember, your output of a decoder is active high. So then only it responds to the logic 1, so that output of the decoder I call it as a min terms. When your decoder output is active high. So let me have the block diagram and its functional diagram, or we call it as a logic diagram, and how this will be works with the truth table. Let me discuss with the 3 to 8 decoder. So remember, we have the 3 inputs and 8 outputs. Always the output start from 0 in the decoder. That should be remember. So here in 3 to 8 decoder, I am considering here is active high output. So in this case, I am getting as the output as min terms. So here in 3 to 8 decoder, we have the 3 input of combinations from 0 0 to 1 1 1 1. So that is 0 to 7. Whenever the input as encountered into the decoder, corresponding one of the output will be responded as logic 1. So for 0 0 0, the Z0 as responded as 1, that is coded into another form, and 001 Z1 and 2 Z2. For 3 it is Z3. Like that, it is all the input combination, it will be converted into another form of coded outputs. So this will be represented in the equation. Let me say that Z0, how I can write with the Z0 as Z0 is equal to X0 bar, X1 bar and X2 bar. That is what we represented here. That is the totally the min term is M0. Similarly, for Z1 I can represent it in as a 1 as in the binary form. That is what we call it as a 8421 code. So it is 8421 code. So in this case, X2 bar, X1 bar and X0. So this is will be represented as M1. Likewise, for M0, M1, M2, M3, M4, M5, M6 and M7, all the 7 output I can represent it in the form of X0, X1 and X2. I can realize in the logic diagram. So the operation, as we understand that, we given the input combination and it is decoded into any one of the 2 power n output lines. So that the input combination can be regarded as a binary number with the consequences that the jth output lines is logic 1 for j is equal to 0 to 7 only when input combination j is applied. It means that your input, let's say I given as x2, x1 and x0, I converted in the binary form. Let's say if you are going to making as 0 0 0, the decimal number this is 0, then your output z0, that is z0, it will be decoded. For example, if I am taken as a 5, that is 101, so your output of z5 is decoded. This is how the decoder works. We'll see the other types of decoder. Function specific decoder with less than 2 power n output exits. Example, decoder with 4 input and 10 outputs in which a single responding output line correspond to a combination of 8421 code. So this is we also called as a binary decimal decoder. Also we call it as BCD decoder. It decoded the BCD number from 0 to 9. So that's what we have, the 4 inputs. It works with 8421 code, and we have the 10 outputs from 0 to 9 output lines. So here we have the IC 74147. This is one of the decoder. It will be BCD decoder. So example, 4 input 7 output decoder that accepts a 4-bit of 8421 code and used to drive a 7-segment display. This also we can use for 7-segment display. So this is what we call as an octal decoder. So we have the 0 to 7. So totally we have 8 segment. Let's say this is your 7-segment display, so that whatever all we have the 7 with the dot, it will be decoded to, this will be used for displaying the 7-segment. Now we'll see some of the designing of logic system, how we can design by using a decoder. So as we know that we have an n input to 2 power n line decoder is a min-term generator. It means that outputs are min-term. It means that it is an active high output. So that's what we call as a min-term generator. So in this case we are using OR gates in conjunction with an n to 2 power n line decoder. Realization of Boolean functions are possible. So let me see that do not corresponds to minimal sum of products, are simple to produce, a particularly convenient when several functions of same variable have to realize. So I am going to be using 3 to 8 decoder to realizing of 3 variable functions. Let me have the function x0, x1, x2, 3 variable. So this is the SOP expression. In SOP expression we have the min-term as m1. I can represent it as in the form of 001. So 001, that is x2 bar, x1 bar and x0. So this is the form where I'll get the output for here is x2 bar, x1 bar and x0. Then plus I'm getting m2 I'm getting as 010 x2 bar, x1, x0 bar plus. So here all these product terms represented as a min term, and after this min term I am supposed to do the plus operation, that is what we called as I need to use the OR gate. So that's what all we are taken as 1 and min term 2, min term 4 and min term 5. So all the Boolean expression at last I supposed to do the OR gate. So here to implementing that SOP expression with active high outputs I am using the OR gate. So this is your SOP implementation. Similarly, one more example, 157. So I am taken as 1 and this is a 5 and 7. As usual, SOP expression, so that will be implemented by OR gate. Same way, for example, I want to be implement let's say some f3 function with the input of x2, x1 and x0, pi of max term of, let's say I can use that 2, 3, 4 and 5. How I can implement? So as we know that we can know that SOP is always complement of POS. So we have the equation as a POS expression. So I need to convert it into the SOP expression, so that I should take the complement of this form. So complement of this form in the sense I use the 2, 3, 4, 5. So I am using 2, 3, 4 and 5. So I am using the same OR gate, but I supposed to take the complement to get the POS expression. So I am using the complemented in the sense NOR gate. So this is your F3. So here it is a POS expression. The gate is NOR gate. This is how we can implement if you have the active high output with SOP expression as well as the POS expression by using OR and NOR gate respectively. So similarly, min term using NOR gate as we discussed. So here SOP complemented I am getting as a POS expression. So what I am getting as f1, x2, x0 I am taken as a 0, 1, 3, 4, 5, 6. So this is your SOP expression. So I supposed to take the complemented of this. So whichever the remaining min terms are, I am taken as a 2 and the 7. So this is the POS expression. This expression I can implement by using NOR gate. Similarly, I'll take the 1, 2, 3, 4, 6. So this is your SOP expression. Complement of this 0, 5 and 7 I can take. So connected to the NOR gate. So this will be I am getting as POS term, POS equation. Remember, as we know that we implemented for SOP using the OR gate, so implementing the POS expression I am using as NOR gate. So the next we going to be implementing the decoder by using the NAND gate. So here we will consider your decoder of having the active low output. So active low output in the sense I am getting the min term here So max term, here I'm getting the max term. It means that inversion of your min term. So I'm getting the max term. Similarly, so here is 0 0 0. It works with the z0 as a max term. For 0 1 it is z1, 2 3, like that I'm getting as a max term decoded output, that I can realize the expression for z0 is equal to, so z0 is in complemented form, so I can write it as a z0 bar, so that is a 0, I can write as x2 x1 x0 bar. So z0 is equal to x2, so this is x2 bar bar bar, x2 plus x1 plus x0. So this is what I am getting for a Poisson equation. So that is what here I am getting the max term of m0. Similarly, for decimal number for 0, z0 has decoded as a max term, 1 I am decoded as z1. So these are all your output as active low outputs. So now we will take the some of the equation to implementing that. So let me have the, so here I am getting as a max term. Max term in the sense I am getting as a sum term. So here I am using that product term. Product in the sense I can use that the word as dot. So you want to implementing some expression, so I can use the AND gate. So I'm getting the sum term here, all the terms as a max term. So I need to making as a product, so that is a SOP. So I am supposed to use the AND gate. So similarly, here the function is 0 2 6 7. So I'm taken as a 0 and 2 and 6 7. So for f1, so I can implement it as a complemented form, that is remaining one is 1 3 and 4 and 5, so that I can implement it complemented terms here. This is the SOP expression. SOP 1 I can implement by using remaining term as 1 3 4 5 by using AND gate. Similarly 3 5 6 7, so here I will take the remaining terms as 0 1 2 and 4 terms to be implementing f2. f2 is taken as 0 and 1 and 2 and 4 by using the AND gate. If you want to take the same term, you can use for NAND gate. So here if you want the let's say I'll take f3, let's say I can implementing pi of m of let me take it as 3 4 and 5. So let me take it as, here it is all the POS form, product of sum. So I can directly take the values as 3 and 4 and 5. So I'm getting here as a sum term. So then I want to use the product. So I use NAND gate to implementing this F3. So inverting of, because here we getting a inversion to this. So this is how we can implement the Boolean function by using your decoder. So one more we can use for decoder with the enable input. So why we using the enable? So here even if you are not given any input, it is 0 0, it is decoded as Z0. So always the output it is read by Z0 even if you are not given the input. So that's what I want to protect my device to be used for enabling the device. So this is the input I given as an active high. Whenever I make this as 1, then the device is enabled so that your output will be response to the corresponding input. So if you are given as 0, you can give any kind of input here. So your device is disabled. So then it will be, your output will be 0 only. That's what we are using the enable line. So when disabled, all outputs of the decoder can either be a logic 0 or logic 1. Enable input provides the decoder with additional flexibility. The idea is data is applied to the enable input. So that is process, whatever enabling process we call it as demultiplexing. So as we know that 2 to 4 decoder, it works with active high. This is 1. So Z0 is X0 bar, X1 bar, E. Z1 is that is 0 1, X0 0 1 in the sense this is 0. This is X1 bar, X0 into E. Z2 I can write it as 1 0, X1 X0 into E. Z3 X1 X0 into E. So this is the equation along with your enable inputs. Even here X0 is equal to 0, X1 is equal to 0, then data appear on the line is Z0 along with your enable. So enable input are useful when constructing larger decoder for smaller decoder. So here we can realize the 4:16 decoder by using 2 to 4 line decoder. So in the 4:16 in the sense, let me have the combination ABCD. So here the combination is like this: 0 0 0 0 and 0 0 1 1. This is one combination with the input, and the next we have this 0 1 0 0, and the same we can have 0 1 1 1. So this is one, we can use one combination. This is another combination, and we'll take the 1 0 0 0. This will be taken as 1 0 1 1. This is another combination, and we have this 1 1 0 0 to 1 1 1 1. This is another combination. So 4 inputs. In this 4 input, the varies from 0 to 15. Now, so this I can realize by using 2:4 in the sense I supposed to take the 2 input for my decoder, so that I can differentiating this line. So whenever is CD as your input, so let's 1 2 to 4 decoder I can use, and this is 1 2 to 4 decoder, and this is 2 to 4 decoder, and another 2 to 4 decoder. So totally I can get it as how many outputs? 4 plus 4 plus 4 plus 4, 16 I am getting with the 2 inputs. But I again AB has also be there for selecting this. So whenever AB is 0, so this is your AB and this is your CD. So this is your D and C. So whenever it is 0 0, here this will be selected as 0 line, and this will be enabled. This 4:1 mux, first 4:1 mux will be working. This is the first one. and then next AB as 0 1, so this is 0 1, the second decoder is working, and 1 0, this is 1 0, third decoder has to be enabled, and this is your 1 1, fourth decoder has to be enabled. So like of the 4 input combinations, your 4:16 decoder has realized. Thank you very much. Hi students, now we will look on the encoder. In this encoder, definition of encoder and different forms of encoder, what are the application of encoder with functional diagram. Encoder provides for the conversion of binary information from one form to another form. It is a reverse operation of your decoder. So encoder are essentially the inverse of a decoder. So here we have the 2 power n input lines to the n line encoder, in which an assertive logic value on one of its 2 power n input lines causes the corresponding binary code to appear at the output lines. So here we have the 2 power n input lines and n line encoder. So here the functionality diagram, we have the 8 inputs. So x0, x1, x2, x3, x4, x5, x6, x7. I'll tell you what are the disadvantage of basic encoder, what are the problem encounter in encoder, overcoming of that, what we are come to the encoder, we'll see that. So here the block diagram. So whenever the z0 is equal to, we can make that x1 to be a one line encoder. Okay, so we'll see that what is your z0 is equal to x1 plus x3 plus x5 plus x7, x2, x3, x6, x7, x4, x5, x6 and x7. This is your align encoder circuit diagram with the Boolean expression. In general, the Boolean expression of the output Zi is the sum of each input xi, in which the binary representation of j has a 1 in the 2 power I bit position. Here we can see that we have the input, that is a 2 power n input. So here it is start from 0, that's what 2 power n minus 1, and we have the n minus 0 to n minus 1 output, that is n outputs. So this is, here have the 2 power n is to n encoder. So in this case, what are the main problem will encoder it is having, in that we'll discuss now. Let me take the 4:2 encoder. We have the 4 inputs. We have, let's say, x0, x1, x2 and x3, y0 and y1. 4:2 encoder. It's a basic encoder. We'll see the functional diagram for this x0, x1, x2 and x3. This is your output y0 and y0, y1 and y0. So if you're not given any inputs, what you supposed to have this? So if you're not given any input, obviously you will get the output as 0. Let me give it as x naught as 1 now. Now it is encoded as 0, x0. Similarly, x1 as 1. Now it is encoded as 0, 1. Similarly, next is x2 is 1. So it will be 1, 0. Next we have this 1, 1. So now we can see what is the problem here. So what is y0 is having x2 and x3. So y0 is equal to x1 plus x3 and y1 is equal to what is the x2 and x1. x2 and x1. So if you're not given any inputs, you're getting as 0. If you're given as x0 as 1, you're getting as 0. How do you differentiate these two inputs? So this is the one basic problem. Let me give it as x1 is equal to x2 is equal to 1. What are you getting now? Equal to 1. Let me consider the input x1, x2 is equal to 1. What will get the output? So x1 is 1, so here x1 is 1, so y0 is also 1. So here x2, x1 both are 1, 1, so y1 is also 1. So we are getting the output y0 and y1 as 1, 1 when both the input x1 and x2 is equal to 1. But the output whatever I am getting as 1, 1 when we given the input as x3 is equal to 1. But this is the wrong output when you given as x1 and x2 as 1. So these are the two problems facing in the basic encoder. How to overcome of these two problems? So to implement whatever the functions by using priority encoder. Priority encoder. So here we can see what are the how we can implement by using priority encoder. Let assumption that the most of the single input to the encoder is asserted at any time is significant in its operation, as we discussed in the same thing when x3 1 1 at the time of this is for whatever the 8 is to 3 encoder. So the priority encoder it's a scheme assigned to the input lines so that whenever more than one input line is asserted at any time, the output is determined by the input line having the highest priority. Let me have the priority encoder truth table. Here I am taken as the 8 is to 3 priority encoder. So I am taken as 8 is to line priority encoder. So we have 8 input lines, x0 to x7. We have the 3 outputs, z0, z1 and z2 with a valid output. So for example, if we govern as all our input as 0 0 now, all our input as 0 0. So this is not a valid input, so that you're getting the valid as 0. It indicates that your input is not valid. So now I'll given the x0 as 1. So here I'm considering this is your highest priority. X0 is in highest priority compared to X1, so that it is encoded as X0. So remember, X0 is in highest priority and X7 is your least priority. So when you given as X0 as 1, so it will be encoded as 0. It is in valid input. So come to in this case, you can give any kind of input here, 0 or 1. Sorry, I just I made a reverse order here. So this is lowest priority and this is your highest priority. So when this is given as a 1, this should be a 0. This means that it will be encoded as X0, that is 0, 0, 0. It will be encoded as 0. So the next highest priority is X1. So you can give X0 as 0 or 1, but it is taken as an X1 only because this is an highest priority compared to X0. So the priority is rising towards to this highest. So then it will be encoded as an 1. So similarly X2, it will be 2. Likewise, it is encoded to all the outputs. So here I given the priority as X7. Now the first problem, this is the distinguishing between the 0 and X0 as 1. So I can differentiate the output with the 0 and the valid output. So now I can give the let's say X3 and X4 is equal to 1. So here I can give then X3 is also 1, X4 is also 1. At any time I can give it as so let's say X3 is 1, X4 is 1. So X4 is an highest priority, it taken as highest priority X4, so that will be encoded as 4, that is 1000, it is encoded. So this is how we can eliminate the problems in the encoder. So this is your priority encoder. So the output is determined by the asserted input having the highest index. Highest index is the X7. So Xi has the highest priority than Xj if I is greater than j. So valid indicates that at least one input line is asserted. This distinguishes the situation that no input line is asserted from when the X0 input line is asserted, since in both the cases, that is Z1, Z0, Z1, Z2, when is equal to 0, 0, 0. Thank you very much.